All right, everyone. Good afternoon once again. I hope I'm audible and my screen is visible.
Good afternoon. Yes, it is.
Great. Because I think in the interest of the time and the respecting the time of each and every individual, I think let's start with this session. Okay. Guys, let's start. Because who is taking the lead and updating us on the topics which we covered in the last session? Who will be taking the lead? Any volunteer? Or do you want me to do that?
The few topics I remember from yesterday is the
Yeah,
history
you
of
don't
Six
have to.
Sigma.
Yes, you don't have to tell me the just. You don't have to get into the details of each and every topic, but yeah, the header and
So,
the broad
so we
topic should
did
be
the
good.
cost of quality, which with the two different types of it, as well as we did the definition of Sigma, the history of Six Sigma,
No,
the
no,
different
no,
levels.
Swati, you are going too fast. Okay, not that way. Okay, at least some explanation. So we started with the definition of the quality, isn't it? We looked at the
Yes,
different definitions of the quality. Then we looked at the dimensions of the quality, right?
yes,
Feature, performance, features, reliability, and durability and serviceability. Then we looked at the cost of the quality, isn't it? Now there are
yes.
four different type of the costs which exist. First one is prevention
Prevention
cost.
cost,
Second one is appraisal
appraisal
cost.
cost,
Operational cost,
Then we have
internal
internal
failure,
failure
internal
cost,
failure cost.
failure
external
cost. Then we
failure.
have external failure cost, isn't it?
Yes,
Then
yes.
we
Yep.
looked at what are the different definitions of Six Sigma. So Six Sigma is used as a problem solving methodology where we have bigger Y and we have smaller axis, isn't it?
Yes.
Then we have Six Sigma is used as a metric where it is used as a common yardstick of measurement for comparing the different processes with each other. Then we looked at Six Sigma as a management system where we have three different methodologies or three different frameworks, in fact, DMAIC, DMADV, and
Yeah.
DFSS.
DFSS.
DMAIC is used for the improving the existing business processes. DMADV is used when you want to build a program from the base and from the starting, and you are saying that you will try to make a program in such a manner that there are hardly any defects which can occur, right? So you are trying to re-engineer it in a different manner altogether. That's when you would be going with DMADV. Design for Six Sigma use when the further improvement cannot be bringed in just by using the DMAIC methodology, and the redesigning of the program needs to be done, which we call it as BPR, business process engineering. That's when you would be using your DFSS, isn't it? That's what we covered. What else did we
Yeah.
covered?
The results of, I mean, basically the GPMO for Six Sigma.
Yeah,
So you
yeah.
give us an
So if my
example as
process is
well.
operating at 5 sigma, then the number of the defects which we would be making in 1 million is 230. If my process is operating at 6 sigma, then the number of the defects which you can expect is
0.4.
3.4 defects per million opportunity. And also I at the starting itself, I also give you a glimpse of how you would be able to gauge and identify whether the project is falling under the green belt, yellow belt, or the black belt category by using certain weightages and by deciding certain numbers around it, isn't it?
Yes.
Yeah. So this was the last topic which we had covered in the yesterday's session. Okay. Now guys, let's start with day 2. We start with stats first. Now, guys, what do you think? Why the data is required? What is the purpose of the data? Why do you need the data? What is the end objective of data?
To measure performance and analysis.
For measure performance and for analysis purpose. What would you do by doing the analysis?
Basically to understand where do the gaps currently lie.
Where do the gaps currently lie? Okay. What else? It will help you in which sense?
It will help us taking a decision.
It'll help
Absolutely,
us to
Dipanjali.
identify the root causes.
Absolutely. I am totally in agreement with you, Dipanjali. So what we do first, guys, we first collect the data. The data might be in the raw format, right? So we collect the data, we organize the data using the various tabulation form, and once you have organized the data, you try to interpret the data. isn't it? The end objective behind all this is it will help you in decision making, right? Because that's the reason we say that data is one of the backbone of the Six Sigma. Every activity needs to be driven by data itself. So it should be a data-driven activity rather than just a gut feeling. Let's talk about, guys, this type of the data. I'm sure since most of you are already Six Sigma trained on or certified also on the green belt concepts. Let's quickly look at this. What are the two different type of the data which exist?
Continuous and discrete.
Everyone with me? Continuous and discrete. What is continuous data? What is continuous data?
It is like a date range, or what to say, the numbering
Give me the
will be like
definition. Give me the definition.
definition.
What is this continuous data? Okay, it's okay. Let me just show it to you.
Measurable,
Guys. Agree?
something which can be measured.
Yes, I agree with you. Something which can be measured. Look at this, guys. Continuous data is one, guys. Continuous data is one. Pankaj, you have to be on the mute, please. Pankaj, can you go on the mute?
Yes, sir.
Go on the mute, Pankaj. Lot of I think you are driving and you are listening to the music as well. Now, guys, the continuous data is one which can be broken down into the smaller parts and which will still make a sense to you, or the data which can be measured using some scale or some equipment. Do remember that the data which can be broken down into the smaller parts and which will still make a sense to us, or the data which can be measured using some scale or some equipment, is known as your continuous data. Let me just give you an example of it. Do you feel, can you measure time? Can you measure time? Do we have any equipment for measuring time? Yes, we have, right? Isn't it? You have watches, right? So you can measure the time, amount of time which is taking. Can you break it down into the smaller parts?
Yes.
So I might ask you, what is the duration of today's session? So you might say, Rohit, today's session is will last for approximately 2.5 hours. So you will say 2.5 hours. I will say 150 minutes. One and the same thing, right? Other than the unit, only the unit have changed. Otherwise, the meaning of the data is same. Yes or no?
Yes.
Yeah. How
Yes.
about this? Can you break down price into the smaller parts? So I might ask you, how much amount of money do you have in your pocket? So you might say, I have $1. So you say $1, I say 100 cents. One and the same thing, right? You say dollars, I said cents, right? One and the same thing. How about this height? Can you measure height? Do we have any equipment for measuring the height? We have, right? Can
Yes.
we break down the height into the smaller parts?
Yes, we can.
Yeah. So maybe you might say feet, I might say inches, centimeter, millimeter. How about this? Can we measure weight? Do we have any equipment for measuring weight? Yes, we do have the equipment also for measuring the weight. So we have a weighing machine. So you can use your weight machine or the weighing machine for checking the weight as well. Yes, it can be further divided into the smaller parts as well. So you might say, Rohit, it's 1 kg. I might say 1000 grams. One and the same thing, isn't it? How about this? Temperature. Do we have any equipment or gauge for measuring the temperature?
Yes.
Yeah. So you
Thermometer.
have the, yeah. So if you want to check the body temperature, you have the thermometer. Otherwise, there are other skills as well for checking the temperature as well. How about this? Temperature. Can we measure the temperature? Do we have any equipment for measuring the, I mean to say, for measuring the distance? Do we have any equipment
Yeah.
for measuring the distance? Yeah. So
Yep.
can it be broken down into the smaller parts? It can, right? So I might ask you how much distance I might ask you how much distance is there from your office to your home. You might say, Rohit, it's 10 miles. So you will say 10 miles, I will say 16 kilometers, one and the same thing. It's because 1 mile is equivalent to 1.6 kilometers. One and the same thing, it's just that unit have changed. Otherwise, everything is still the same. Comfortable? So the continuous data is one which can be broken down into the smaller parts and which will still make a sense to you. Or the data which can be measured using some scale or some equipment is known as your continuous data. Like someone already have mentioned that the second type of the data which we have is discrete data. Now guys, what is discrete data? Now guys, the discrete data is one which cannot be broken down into the smaller parts, or the data which cannot be measured, or the data which cannot be measured using some scale or some equipment is known as your continuous, I mean to say, is known as your discrete data, or all data other than the continuous data is a discrete data. Because there are different type of the discrete data. There are 5 different type of the discrete data. Let me just show you 5 different nature of the discrete data which actually exist. First one is binomial. Yes, no, true, false, 0, 1, pass, fail. Can you measure it? Do we have any equipment for measuring this? Maybe no, right? Can you break it down into the smaller parts? Can you break it down? Maybe no, right? You cannot break it down into the smaller parts, so there are only 2 possible outcomes in this. How about this? The second type of the discrete data is the count, and count is something which can be counted. So maybe if I ask you how many participants are currently logged in this session, so you will say, Rohit, apart from you, apart from the facilitator, apart from the trainer, there are another 29 individuals. So 30 individuals all in all are currently logged in today's session as of now. Can you say that there are 29.35 individuals who are logged in? Would you be able to say so? Yes or no?
No.
No, right? So you have to consider that in the totality itself, isn't it? If I might ask you how many number of employees are working in your organization, so you can count them up and you can let me know. Will you be saying that there are 20, maybe 100 and maybe 100.5 individuals working in our organization? Will that be a scenario anyways? Will that be a scenario any day? Maybe no, right? That will not occur, because you have to consider that in the totality itself. How about this nominal data? Guys, what is nominal data? The data which have some names or some labels against them is known as your nominal data. For example, let's say you tell me that there are 1,000 employees who are working in your organization. You might say that there are 1,000 employees who are working in your organization. I might ask you to categorize the individuals on the basis of their on the basis of their department. Would you be able to do so? On the basis of the department, would you be able to categorize the individuals? Yes, no, maybe. Yes, let's make this more of an interactive session rather than just one side download. I will
Yes,
keep on
Rohit.
speaking and I will just keep on moving. I will not even understand, even how would I able to understand whether you are able to grasp what I'm just telling or not. It's a one-way communication which is going on. So if you want to make it a training program, or I'm okay with it if you don't want to make it a workshop. Okay. So now guys, the nominal data is one which have some names or some labels against them. So I might ask you how many would you be able to categorize the individuals on the basis of their designation? Maybe you might say yes, Rohit. You might be able to categorize them on the basis of their designation. Maybe you will say that there is one CEO within the organization, there are 2 senior VP, and there are maybe 10 senior manager, there are 30 managers, and maybe there are 20 again, maybe hypothetically 20 team leader, and remaining are the individuals who are working at a lower level or who are working at a associate level, isn't it? So you would be able to easily categorize them as well on the basis of the department or the designation. There's the fourth type of the discrete data is ordinal data. Now, what is ordinal data? Like the name is suggesting, ordinal. So it is following certain order or some sequence. The data which will follow certain order or some sequence is known as your ordinal data. Take this example: excellent, very good, good, fair, and poor. Have you ever participated in any kind of a survey where the Likert scales are there? You might be asked to give the ratings, isn't it?
Yes.
These are
Yes.
the kind of the rating scales which might be there: excellent, good, very good, fair, poor, or maybe outstanding as well, right? Now tell me, can you put good between excellent and very good? Can you put good between excellent and very good?
No.
Maybe no, right? You cannot, right? So you have to follow certain order and sequence itself. How about this? Strongly agree, disagree, strongly disagree. Again, it is following certain order or some sequence. Maybe the cold, hot, I mean to say cold, mild, hot, very hot. Again, it is following certain order or some sequence. Yeah. Now, guys, there is one more type of discrete data. Let me just tell you that is a debatable topic. You might say that, Rohit, it is considered as a continuous, but let me just tell you, 95 to 98% of the population consider that as a discrete data. Only 2 to 5% of the population consider that as a continuous data. So the professors who actually have taught me this Six Sigma over a period of 15 years from so now, and the publications which I have read, the friend circle which I have, they all consider that as a discrete data. Hence, I will also consider percentage as a discrete data. Since we believe that percentage cannot be measured, we do not have any equipment for measuring the percentage. Hence, percentage would be considered as a discrete data. Comfortable? Okay. Guys, let's do one thing. Since, like I said, this is one of the most important topics of the discussion, I will give you some of the scenarios.
Rohit,
Okay, I will give you,
one
yeah.
question. See, when it comes to percentage, I
Like I
agree
knew,
there is no.
I know, no, Srinath, I will not be answering that question. I know what question you are putting up. Okay, like I said, 98% of the population is going with the discrete data. Now, if the organization in which you are working, and if your master black belt, if your master black belt feels that no, percentage should be considered as a continuous because there are certain decimals after the dots, right? You can consider it as a discontinuous if your master black belt says so. I don't recommend it. Okay, you might be having your own opinion in that scenario. Like I said, I'm sure
Okay,
this
fine,
was the
got it.
question. Yeah. Okay,
Yeah,
guys, I
yeah.
will give you
So no, what my question was, we derive percentage based on some what is it, some
I know.
logic.
And like I said,
So
Srinath, there are people, there are individuals who have their own opinions as well, isn't it? I don't
yeah,
consider that a discrete person as a continuous, since I believe that we cannot measure it. We do not have any equipment for measuring the percentage. Hence, I consider that as a discrete data. Because I
okay,
was just saying that I will give you some of the scenarios, okay? You just try to identify, just try to let me know, categorize them into the two categories, whether it's a discrete data or it's a continuous data, okay? Just try to categorize them into the different categories. Tell me, guys, let's say if you want to reduce the number of errors or defects, what kind of data is it? Let's say you have initiated a project for reducing the number of errors or defects.
Continuous.
Sorry, come again. Not able to hear you.
Continuous.
Continuous. How continuous?
no,
You
it
are
should be
reducing
discrete.
the number of errors, right? Cannot you count the errors?
Discrete.
Yeah,
It should be
It's a
discrete.
discrete. It's a
yeah.
discrete
Discrete.
data, guys. It's a discrete data. Since you can count them up, you can count the number of errors. It's a discrete data. Mm.
Hmm.
Let's say if I want to initiate a project for reducing the cycle time of processing an application. Now tell me what kind
Continuous.
of data is it?
Then the continuous one.
Continuous, because it's in time, right? Isn't it?
It's measurable.
Now, yeah. Let's say you want to improve upon the CSAT score.
Discrete.
Others
Yeah,
also please participate.
Discrete.
Discrete, right? Okay.
Yes.
I want to improve the accuracy and the quality score.
It's a continuous.
It's a
Continuous.
discrete.
It's
It's a
measurable.
discrete one because it's a discrete one because accuracy and quality is into the percentage, right? Isn't it?
Percentage. Yeah.
That's you say process is operating at 60% accuracy or quality score is 98% currently. Yeah. Let's tell me about this. I want to increase the number of deliveries which the rider is making per day.
Discrete.
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 as
Okay.
it is a count.
I want to reduce the attrition percentage.
Discrete.
Discrete.
Okay. I want to reduce the average handling time, EHT.
Continuous.
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 Continuous, since it is in numbers,
Time.
right? So you can measure it, right? That's in time. Very good. Let's talk about this, guys. Central tendency. Now you don't have to get into the literal meaning of the definition of the central tendency till the time you are able to understand the type of the central tendency or the methods of calculating the central tendency. We are okay with it. Now, central tendency is the tightness of the data around the central point, or how tightly the data is clustering around the center, is known as your central tendency. Okay. Guys, there are three main common measures of central tendency. I'm sure you might have heard about them. So first one is mean, second one is median, and the third one is mode. Have you heard about them? Mean, median, mode?
Yes.
Yeah.
Okay. Very good. Let's study them, guys. What is mean? Mean is just the arithmetic average of a set of data, isn't it? It is just the
Yeah.
arithmetic average of a set of data. What in order to calculate mean, what you have to do, you have to sum all the values and you have to divide that by the number of the observations, and that will give you your mean or the average value. Would you be able to calculate the mean in this example? Easy, right?
Yes.
You can sum all these observations, which are 11 or 12. You can sum all these observations and you can divide that by the number of the observations. That will give you your mean or average value. How about this? Would you be able to calculate mean of from this example as well?
Yeah.
Yes.
Yeah, just sum them up and divide that by the number of the observation, and that will give you your mean or the average. How about this? Again, easy,
Yes.
isn't it? Again, easy, right? So you can just sum all these observation and you can divide that by the number of the observations. All right, okay. Read out this. Just tell me first thing before I tell you about this. What are the different methods of calculating the mean? Tell me. What are the different, though it's not into your course, but still, what are the different methods of calculating the mean? What you told me is sum all the values and divide that by the number of the observation. This is the arithmetic mean. Which other methods are there for calculating the mean? Tell me, anyone?
Average out all the values.
That is just arithmetic mean. That is the arithmetic mean, what we looked at. There are two more methods. First one is the geometric mean, and the third one is the harmonic mean. Heard about it? Geometric mean and harmonic mean?
Can you
At
come
least in the
again? Your voice is slipping, Rohit.
my voice is slipping. Okay. So there are two more methods of calculating the mean. First one is the geometric mean, and the third one is the harmonic mean. All right. It's not, we are not getting into that detail, but yes, it's a good to know information for you. If you wish, you can study that as well. What is geometric and what is harmonic? But trust me, you will never be using the geometric mean or the harmonic mean ever. Let's read out this, guys. On a very hot and a humid day, you are walking through a jungle. Oops. You are walking through a jungle and you came across a lake where it says average depth is 4 feet. Okay. Now, guys, the average depth is only 4 feet, and you want to pass the lake Now there are two conditions attached to it. First condition is you are 6 feet tall, and the second condition is you do not know how to swim. So you do not know how to swim, you are 6 feet tall and you want to pass the lake. Now tell me, would you pass the lake? Would you take the risk of passing the lake? Yes or no?
No.
Yeah.
You are 6 feet tall, guys. You are 6 feet tall and the average is
Yeah.
just 4 feet.
I will take the risk.
That average is a 4, but it depends in the depth in the each places. Maybe
Okay,
the depth will be
yeah, just mention that, guys, in the chat window. How many of you are saying you will pass and how many are saying you are saying no? How many are saying yes for passing? How many are saying no for not passing?
Average doesn't mean that the overall maximum depth is 4 feet. It says it's only the average. So there may be chances of higher, deeper things also. So it depends on the maximum depth.
Yeah, absolutely. So whosoever, guys, whosoever thought of yes, they will take the chance of passing the lake. Guys, this will happen to you. This could have happened to you. You would be at the bottom of the lake. Why? Because you have taken the decision just on the basis of average, which is not the right measure of taking the decision out here, right? So one of the methods, see, look at this. See, let's say there are 5 points in the lake. First point is 1 feet, second point 1 feet, third 1 feet, fourth 1 feet, and fifth point is 16 feet. How much is the total of all the 5 data points? 16 plus 1 plus 1 plus 1 plus 1 makes it 20, right? Divide by 5 makes it 4, isn't it?
Yes.
So it looks like average is 4, but till the time you are moving at a place where it's 1 feet, we are okay with it. However, as soon as you will step at a place where it's 16 feet, you would be at the bottom of the lake, isn't it?
Yes.
Because you have just taken the decision on the basis of your average. So what more information should I provide you to take the decision?
Highest value we should know.
Max depth is also required. Max depth.
Yeah. So if I can provide you the maximum depth, in that scenario, you would be
range.
able to take the, not the range. If I provide you the maximum depth, in that scenario, you would be able to take the decision, isn't it? Correct? Very good. Look at this. These are two different groups, okay? These are two different groups, group A and group B. The average of group A is 6, excuse me, and the average of group B is also 6. Okay. The average of both the groups is 6. Which group do you think is much better, A or B?
B.
B.
B. B. Why B?
The
Because the
variation
data
is less.
The consistency is
Vari-
more in group B.
Consistency is more in group B and the variation is very less, isn't it? So all these observations are very close to your target value, right? Which is 6. Yeah, because the another objective of doing Six Sigma, or the another definition of the Six Sigma is, maybe this, you can say that Six Sigma focuses on reducing the variation. So reduce the variation as much as you can and your process will become furthermore better and streamlined. Comfortable?
Yes.
Yes.
What's the second method of measuring the center tendency is your median. Now what is median? Median is the positional value, guys. Do remember, it is a positional value when arranged in the ascending or in the descending order. So before calculating the median, it is important that you should be arranging the data points into the ascending or in the descending order. And formula for calculating the median is n plus 1 divided by 2 tth item value. So how many observations are there in this example?
7.
How many observations? 7, right? So what we have done, we have arranged the data points into the ascending order from the lowest to the highest. So formula is n plus 1. So 7 is the, n is your 7 plus 1 makes it 8 divided by 2 makes it 4,
4.
right? So 4 is not your median, but the positional value, like I said, it's a positional value. So you have to count the 4th place. So if you just count them up, 15th is at 4th place. So your median is 15. So
15.
you can also call it as it's a middle number. Now guys, there is one of the properties of median, and that property is that the equal number of the observations will lie above and below your median value. Okay, equal number of the observation will lie below and above your median. Would you be able to calculate the median in this example easily? You can
Yes.
arrange them data point into the ascending or in the descending order. Then you can use the formula for calculating the median. Comfortable?
Yes.
Rohit, the number
Yes.
of values, the number of data points over here is 12. So you'll have to take an average,
Yeah.
We have to take the average of the middle two
middle
numbers.
two numbers.
Take this. How many observations do we have? 5, right?
Yep,
So what do we have to do first? We have to arrange the data point into the
ascending or descending
order,
order.
ascending or descending order. So how many observations we have? We have 5 observations. Formula is n plus 1. So 5 plus 1 makes it 6. 6 divided by 2 makes it third, right? So first, second, and third. In this scenario, your median is 6, right?
Mm.
How about this? Now, how many observations do we have?
6.
We have 6. 6 plus 1 makes it 7. 7 divided by 2 makes it
3.5.
3.5, right? First, second, and third. So your median lies between these two numbers. So you have to take the average of these two. How much is the average of these two? 8.
8.
So your median is 8. So do remember, if in case the number of the observation which you have are even number, like in this scenario, it's an even number, then you have to take the average of 2 observations. And if in case the number of the observation which you have are odd, then you will straight away get your median without taking any average. All right. Look at this. What is mode?
The number of
What is mode?
times, the frequency of a particular data value.
Yeah.
The
So
maximum
can we say, yeah. So the value or the observation which is occurring for the maximum time or for the one which is repeating for the maximum amount of time is your mode. Look at this. The mode of a set of a data is the most frequently observed value. How many observations we have? We have 6 observations. When we arrange the data point into the sequencing manner, we notice that 4 is occurring twice and 5 is occurring thrice. So what's your mode out here? How much is your mode? Mode is your 5, right?
5.
Mode is
So
your
reduce the
5
factors to
because
more 2 times.
mode is your 5 because 5 is occurring thrice. Would you be able to tell me the mode in this example?
Yes.
How much is the mode?
8.
8.
8.
8. Okay.
8.
How about this?
9.
9.
9.
9.
Now guys, let me just tell you the little bit usage of the mode where you will find mode. Now guys, the usage of the mode is a little limited in the service industry. It is mostly used in the manufacturing. But still, let me just tell you the usage of the mode. I will just try to give you the examples from both the industries. Take this example. Let's say, guys, just take this example. Let's say there is a let's say you are into the manufacturing of the shoes. Okay, you are into the manufacturing of the shoes, and there are different sizes of the shoes which you can make, ranging from 8, 9, 10, 11, and 12. Okay, now tell me, if you have to make 10,000 pairs of shoes, would you be making the 2000 shoes for each sizes? Would you be able to do that? Would you be going with that approach?
No, you would actually find out
No.
your skills which has been sold more with size.
Yeah. Yeah. So either you will be doing some kind of market survey to look at the shoe which is most sold out, right? Or you will, if in case you have some historical data, you will try to identify the size of the shoe which is most sold or which is mostly purchased by the customer, isn't it? Only then you
Yes.
will decide that in which frequency you will be making the shoes itself. Maybe once you do it, you notice that the shoe size which is most sold out is of size 9, for example. Hypothetically, let's say it's size 9. 50% of the shoes is of size 9, so which means that if you have to make 10,000 shoes, you would be going with the 50% of the shoes which are of size 9, right? Isn't it?
Yes.
Getting my point?
Yes.
And remaining you can distribute that again in the order of their purchased. So guys, let me just tell you another example from the service industry this time. Let's say, guys, within your processes in which you are working, there are a lot of errors or defects which are happening upon regular basis. And once you started capturing the data, you identified there are 10 different nature of the defects which the process is making. Okay, 10 different nature of the defects which the process is making. Now your end objective is to reduce those errors, isn't it? That's the end objective. You want to reduce those errors.
Yes.
And would you be able to work upon all the factors on all the defects in one go? Would you be able to identify the solutions for all the parameters in at the one go itself, or would you be prioritizing them?
Yeah, we
Prioritize.
have to prioritize them
You have to prioritize them, right? And on the what basis would you be able to prioritize?
on the
The impact.
frequency of occurrence.
Variance.
On the basis of the mode again, right? Isn't it?
Yeah.
Yes.
The error or the nature of the error which is mostly occurring or most of the time which is causing error, the parameter, you will try to identify the solution for that specific parameter first and later on move on to the remaining parameters, isn't it?
Yes.
Comfortable?
Mm.
Very good. Now guys, tell me any questions guys on mean median mode so far?
None so far.
No. Now tell me guys when to use mean and when to use median.
Hey, can you just tell me about the harmonic mean that you use?
No, we don't have to get into that detail, Dinesh. That's just a good to know
Okay.
information for you.
Okay, fine. Thank you.
When to use mean guys and when to use median? When to use mean and when to use median, because just learning mean and median is not the objective, guys. You should know when to use mean and when you should be able to use median in your business processes. Any one of you? Best, I hope I'm audible.
Mode can be used if a specific once we get a different types of errors to identify which error is causing more or number of times it is causing.
Not mode.
Then we can use mode.
Not mode. No, I'm not talking about mode. I'm talking about mean and median.
Okay.
When to use mean and when to use median. It's okay, guys, if you're not aware of it.
I mean, it's when your data is something like a discrete, we can use mean.
No, that is not
Not
the
sure
logic.
I'm
No, that is not the logic, Srinath.
Rohit, for my understanding is like if you have a huge number of data in that, a lot of variations is there.
I agree.
Then
I agree.
if we are going to remove the outliers, then we can go with the mean. If you have planned to not remove the outliers, then we can go with the median.
Absolutely. Bang on, Mr. Babu. Absolutely. That's the right answer. Let me just show it to you guys. Just take this example. let's say these are a couple of the individuals who are in the class or in your maybe in this group. Let's say there are some individuals and I have their heights. Okay, well, I'm just taking hypothetically, guys. This is the height which is in feet. First individual is 5.5, maybe second one is 5.7, maybe 5.4, maybe 5 point let's say 6, and maybe again 5.8. If I have to check what is the average height in this room, can I do so? How much is the average height in this room? Average height in this room is approximately 5.6. Will I be correct in saying that the average height in this room is 5.6 feet approximately?
Yes.
Yes.
Let's say one of the tallest person also joined this training session, and he is quite tall. Let's say he's quite tall. He is, let's say, hypothetically, let me just say it's let's say 7.2 feet. Do you think the average height in this room is 5.9 feet? Do you think this is the right depiction
No.
of the height in this room?
No.
Yes or no? No, right?
No.
Isn't it?
No.
Yeah. So let's try to do one thing. Let's try to calculate median. So what we have to do, we have to arrange the data point into the ascending or in the descending order. Now, how many number of observations we have? 6, right? 6 plus 1 makes it 7. 7 divided by 2 makes it 3.5. So first, second, and third. So your median lies between these two. How much is the median coming up? 5.65, right?
6.5.
Do you think this is the right depiction of the average height in this room? Isn't it?
Yes.
Yeah. So which individual is this? Who is this individual?
Outlier.
He is an outlier,
Outlier.
right? Outlier. Or maybe just take this example. Let's say there is another individual who is quite short in the height and he is only 4 feet. Do you think the average height in this room is 5.3? Maybe no,
No.
right? So let's arrange again into the ascending or in the descending order. We have this individual who is a outlier. How many observations? 6 plus 1 makes it 7. 7 divided by 2 makes it 3.5. So your median again is 5.55. Is this the right depiction of the average height in this room?
It's more closer.
It's much closer, right? Isn't it? Because
Yes.
this again individual is a outlier, right? Guys, trust me, if in case you have outliers in your data point, you have two different options. Okay. First option is either you can remove the outliers, then calculate median, or you can go for your median. See, removing the outlier might not be possible for you. Why? Because over here, how many data points do we have as of now? 6 or 7, right? Isn't it?
6 point.
But in the real life, when you would be working within the organization, you will not have 7 or 8 data points. You will have thousands and thousands of the data point, isn't it? That point of time, removal of the outliers might not be a possibility for you. So you have to just check the both average and the median as well. If there are huge amount of variation is there in the data points, go for median. Otherwise, go for your mean value. Comfortable?
Just reconfirming, if there is a too much of variation, we'll go for median.
If the
If there is no
variation
variation,
is what? No. If the variation, come again, Dinesh.
if the variation is too much between average, median, and mean and median, then we'll go with median, right?
Yeah. If there is a huge amount of variation within the data points,
Okay.
go for median. Otherwise, you can go for a mean as well, because there can be some individuals who might be an outlier. See, guys, mean has a tendency to take the data points either side, right? It has a tendency to move towards the outlier, either upside or the downside.
Rohit, I have a question here.
Anji, yeah, ask me.
Yeah, Rohit, Actually, if we know the minimum outlier range or the values needs to be removed or maximum, so that once we remove the outliers as per the process or knowledge what we have. So after that, if we are going with mean or median, what approaches will be fine, right?
In that scenario, you can go for mean, which since you have already removed your outliers, it's okay. You can go for your mean value. That is more
Oh,
used. See, leadership team will understand mean more rather than the median, isn't it? It's
yes,
easy to
yes.
convince leadership team on the mean value. They will understand mean and the average more rather than the median. This is more for the Six Sigma professionals that we go for the median and we try to do the analysis. Getting my point,
That's
guys?
the reason. Yeah,
Yeah.
because I have done some analysis. I have removed all the outliers. After that, I have provided the AST to the management. I have provided in the mean model. They are not convinced. They are requesting for the median model. That's the reason I have asked.
Just check for the median value, how much variation is there.
It's
Just
very little only.
yes, so still you can let them know that you have checked that for the median as well, and there's not much
Mm,
difference which is coming between the mean and the median. Hence, mean, see, every whatever you are trying to do will never be 100% right, isn't it? You can
mm,
only do the
yes.
approximation. So you can let them know that yes, you have checked both the mean and the median, and the variation and or maybe the difference between both the mean and the median is very less. Hence, mean is also the right approach over there.
Okay, Rohit. Thanks.
Or you can also do one thing. You maybe, let's say if you have the entire population set, you can remove outliers from both the sides, from both the angles. Okay, you can remove top 5% of the population and below 5% of the population. The remaining 90% which is there at the bottom, you can calculate the median from it or mean from it, I mean to say. That will also work.
Okay.
That's a different approach altogether. I guess let's talk about measure of spread for a moment. Whereas the measure of spread is the extent or the amount to which an observation in a sample or in a population varies about its mean is known as your dispersion or spread. Guys, there are different measures of spread. Let me just show you a couple of the measures of spread. Have you heard about these three measures, range, standard deviation, and quartile? Have you heard about them?
Range and
Oh,
standard
yes.
deviation.
Have you heard about all three of them, range, standard deviation, and quartile? Okay,
Range and
let's study
standard
them.
deviation, yes.
Yes.
Quartile is something.
Let's study about quartile as well. I will just show you each one of them. Now, what is range? What is range?
And the minimum
Different. Yeah,
MSL to
the
ML,
the difference between the maximum value and the minimum
LSL to
value.
MSL is range.
Yeah, so the difference between the maximum value and the minimum value is known as your range, right? Range is defined as the difference between the maximum and the minimum observations of the values. Now, guys, it tells us about the total spread of the observation. Range is based on two extreme observations. It gives no weightages to the central value of the data. Look at this data, guys. Group A, can you tell me the range? Can you tell me the range in this example?
30 to
How much is
50.
the range?
30 to 50.
30 to
50.
50, right? 30 to 50, which is 20.
20.
How much is the range in this group?
30 to
20.
50.
30 to
50.
20.
How about this group C?
Same.
30 to 50.
20, right? Again, in all the
Same.
three groups, the range is same. But do you think all the three groups are identical?
No.
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 It is no, right? Because range is only based on the extreme observations. It does not give the weightages to the central value of the data or the data points which are at the middle. It does not give any value to them. So though it is one of the measures of spread, but it is not a very good measure as well. So hence, in order to remove the deficiencies which are coming from the range, you can go with another method which is considered as a best method of calculating the variation or the dispersion, is standard deviation. Can you tell me the range in this example? How much is the range?
39
How much is the
and
range?
188.
How
39 and
much is the
188.
minimum? How much is the minimum?
39.
39.
39 is the minimum and the maximum is
188.
188.
188.
How about this?
7.
7.
7 is
7
the
is the
minimum
minimum.
and maximum is
155.
177. How about this?
3 is the minimum.
3 is the minimum and
189.
189 is the
189 is
maximum,
max.
right? So 186 is your range, isn't it? Yeah.
Yeah.
Easy. Very good.
Yeah.
Let's talk about this, guys. Measure of spread, which is standard deviation now. What is standard deviation? How would you define standard deviation for me? Tell me. What is standard deviation, guys, and where it can be used? How do you calculate your standard deviation? There
Set
are
of
24
data from the mean.
set of?
Data from the mean.
No. There are 24 individuals in this session who are already trained on the green belt.
Rohit, I think it's the deviation from mean.
Which is right, Umesh. You have to add one more point. You have to add one more word over there, then your answer would be right.
Standard deviation may be a quantity of expressing how much is the numbers.
No, maybe what Umesh you just said is right. You just have to.
Standard
Yeah,
deviation is
yeah.
the average of how much the value is away from the mean.
Absolutely clear, absolutely bang on. So standard deviation is not the distance of the data point, but is the average. So the average is the most important word out here. Okay, standard deviation is the average distance of all the data point from your mean value. How far on an average data points are from your mean value. Okay, now the formula for calculating the standard deviation is this. I can show you the formula as well, or do you want to learn just using the Excel file, or both? Tell me, which approach would you prefer?
Both.
Both?
Both.
Okay, I will give you the both the approaches then. Easy, again, taking the easiest of the example, simplest of the example. Let's say these are 5 data points which we have, which are 1, 2, 3, 4, 5. Okay, how much is the average of these? How much is the average of all these data points? 3, right? Isn't it? 3 is the average. Now it says average
Yes.
distance of all the data points from your mean value, which means that you have to take the average distance of each and every data point from your mean value. So your x minus your mean.
Mean.
How much is the difference between these two?
-2.
-2. Okay. Same way you would be able to do that for the remaining observations as well.
Yeah.
How much is the sum total?
0.
0, right? Sum total is 0. Would you be able to make any head and tail out of 0? Would you be able to make any information out of 0?
No.
No, right? You will not be able to make any decision on the basis of 0. Hence, you have to do something. What you have to do, you have to square this on. Maybe you have to square d over there, over here itself. Look at this. How much is it
4.
coming up?
4.
4, right? How much is the total?
10.
10, right? Very good. Let me just copy and paste this data. Example, I'm going to say this formula. It says at the numerator, just look at this. It says summation of xi minus x bar square. So this is your summation of xi. This is your all xi, and this is your mean. Okay, and you are doing a square of it. Then you have to do a summation. So your summation xi minus x bar square is how much? 10. How many number of observations do you have?
5.
How much is your n?
5.
5. N minus 1 is how much?
4.
4.
4. So how do you calculate the standard deviation? It is square root of 10 divided by 4. Your average distance of the data point from your mean value is 1.58 units. Okay, so this is the amount of the variation which is observed on an average between the mean value and the remaining data points. Comfortable?
Rohit, my apologies. Can you just explain the formula one again?
Formula. Okay, you understand this? N minus 1.
The number of
N is
observations minus 1.
are 5. N minus 1 is 4, right?
4.
5 minus 1 is 4, isn't it?
Yeah.
What do you have to do? S stands
4.
for standard deviation. S stands for
Okay.
standard deviation, which is equivalent to what do you have to do? You have to take a square root
Square.
or under root of something, right? And what do you
Yes.
have to do? You have to take a summation of something. What is something? This summation. Summation xi minus x bar square. So this is your xi1, xi2, xi3, xi4, xi5 till xi, okay? x1, x2, x3, x4 till xi. Now summation difference of these two, this and mean is square. This is what you have done, isn't it?
Yes.
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 Now it
Yeah.
says summation. Summation is nothing more than the sum total of all the observations, right? You just sum all these observations and
10.
how much is it coming up? 10. So
10.
your top is how
Mm.
much? Numerator is
10
how much? 10, right? So 10 divided that by
divided
n minus
4.
1, which is 4, and you take a under root of it, and that will give you your standard deviation.
Okay. Thank you.
Comfortable? Now tell me, guys,
Yeah.
why we have done a under root of it? Why we have done an under root?
We
Why we
took
have
we the square of g.
Yeah, just take this example. Let's say when we started this, guys, let's say this was in minutes, okay? This was in minutes. This was my units. Now what you have been able to do, this is in minutes square. So you have been able to change the unit, isn't it? This is again in minute square. Don't you want to come back to the same unit from where you started?
Yes, definitely.
Isn't it? Now, if you want to come back to the same unit from where you started, you want the results into minutes, not into square. So you would be taking a under root of it to nullify the square impact. Comfortable?
Yes.
Yeah, clear.
Very
Yes.
good. Take this example, another example, at least whosoever is in India will understand. So how many of you are from India? Or how many of you are not from India? Maybe that should be the question. How many of you are not from India? Do you watch any one of you? Still okay. Let's continue, guys. I think the individuals did not answer it. Still okay. Let's talk about this, guys. Quartile. Guess what is quartile? Have you heard about the word quartile? Have you heard about quartile?
Yes, sir.
What is quartile? What does quartile does?
Is it basically dividing the data into different quadrants?
Absolutely, Swati. So what does median does? Median divides the data point into how many equal parts?
2 equal parts.
2 equal parts, right? So the word quartile is coming from the word quarter, and we know that the quarter is 1/4, which is 25%, isn't it? It's 25%. So the data can be divided into the 4 regions that covers the total range of the observed value, and the cut point of these regions are known as your quartile. So there are 3 quartiles: quartile 1, quartile 2, and quartile 3. We divide the data point into 4 equal parts. Just take this example, you will understand. Let's say if this is a straight line, okay? Let's say this is a straight line. If I want to divide this into maybe let me just put it this way. Let's say this is this is a straight line. If I want to divide this into 4 equal parts, how many lines should I cut? How many lines should be there if in case I want to divide this into 4 equal parts?
3.
You tell me, 3 or 4?
3.
3, right? This should be my first line, right? Then this should be my second. This should be my third, isn't it? This way we would be able to divide the data points into 4 equal parts, and each part would be
25%.
25%. 25%. Like I said, the cut point of these regions are known as your quartile. So this is your quartile 1, this is your quartile 2, and this is your quartile 3. This is also known as your top quartile or upper quartile, and this is known as your lower quartile or bottom quartile. With me so far, everyone?
Yes.
Now let's say guys,
Yes.
let's say you calculated this value. Okay, this is important. This is something which I will tell you how to do it. Let's say you calculated your quartile 1. Quartile 1 comes as 40%. Quartile 2 comes as let's say, again hypothetically, let's say 60, and quartile 3 comes as, let's say, 90%. What does this mean? What does this mean? What does this mean? Tell me, what does this mean? Quartile 1. What does this mean? It means,
The data set
go ahead,
within
Srinath.
that 40% range.
No, Srinath, your voice is actually breaking a lot. I was not able to hear you properly. Come again. Come again, please. Was not able to hear you.
The data set is
Data set is what? No, not able to hear you. Look at this, guys. What does this mean is, if the value is 40 over here, it means that 25% of the population, okay, 25% of the population is having a score which is less than 40. 25% of the population is having a score above 90. Can you tell me what percentage of the population is having a score above or below 90? What percentage of the population is having a score below 90?
75%.
75, right? So this is important. You should be able to calculate this, and this will help you in lot of things. Look at this. Let's say the accuracy of your team, okay, or the quality score of your team is currently, let's say, on an average is 50%. Okay, this is the average quality score of your team is currently at 50%, and the target which has been given to you by the organization that you have to improve the accuracy score from let's say 50% to 70%. Can you tell me how you would be able to do so? How you would be able to do? क्या करोगे? What would you be able to do in order to take it from 50 to 70? Tell me. Where you should focus your energy upon.
In the lower quartile.
Tell me, how do you calculate this 50? How this you have been able to calculate this 50? So this is the average marks, right? Average quality score. So there would be some individuals. Let's take this example, guys. See, easiest of the example. Let's say in a classroom, there's a mathematics paper which has gone, and the average marks in the mathematics out of 50 is 30. So how do you calculate 30? How you were able to drive 30 as the average marks in the class? There would be some students, isn't it? There would be some students who would be who might have scored 10 marks. There might have been some
Yeah.
students who might have scored 20 marks. There might have been some students who might have scored 50 marks as well. And the average, you might have sum all those marks and divide that by the number of the students. And that's how you would have got your average marks of 30, isn't it? Yes or no?
Yep.
Now, if you want to
Yes.
improve the average score of the class from 30 to 40, what would you do? Would you focus on those students who are already scoring 45 and above, or 40 and above,
No.
or around 50?
No.
You
No.
will focus on those individuals, on those students who are scoring very less, right? Maybe who are scoring only 10 or 12 or 15, isn't it? You will be
Yeah.
you will be scoring those which are weak in the mathematics, isn't it? Getting my point?
Yes.
Yeah.
Okay, same is the scenario over here as well. See, this is your entire process. Okay, this is your entire process in which you are working, and your entire process is operating at an average quality score of, let's say, 50. This is the average score of 50 marks, 50%, I mean to say. Now, how you would have been able to drive 50? Some of the employees would have been scoring a quality score or giving a quality score of 90 and 95 as well. Some of them might be giving 100 as well, but there can be some of the individuals who might be giving a quality score of 20 as well, isn't it?
Yes.
With me now, if I
Yeah.
have to if I have to improve from 50 to 70, what should we do? We should focus our energy upon those individuals who are not performing well, isn't it?
Yes.
Yes.
Yeah. Guys, what we have been able to do, we have been able to calculate quartile 1, quartile 2, and quartile 3. This is something which I will tell you how to do it. Let's assume, let's say quartile 1 is 40. What does this mean? It means that 25% of the population is having a quality score which is less than 40%, and 25% of the population is having a score which is above 90%. So should I focus my energy upon these individuals, or should we try to focus our energy upon these bottom performers?
Quartile one. Quartile one.
Lower quartile, right? Or the bottom performers, isn't it? Once I improve them, maybe what we can do, we can share the best practices between the top quartile and the bottom quartile, or we might ask bottom quartile to buddy up with the top quartile as well, isn't it? Once they do so, their entire productivity of the team will improve, and once the entire productivity of the team will improve, your target would be met. Correct? I just have to focus my attention on these individuals. Comfortable?
Yeah.
Okay. Let's try to
Yeah.
do an example, guys. Let's try to do an example. You will understand this better. Let me just take another hypothetical examples. Okay. Let's say, guys, these are some of the data points. Okay. What did we learn so far? What we covered was a central tendency, isn't it? What did we cover in the central tendency?
Mean median mode.
The data to the central point.
What we covered was the mean median mode, isn't it?
Mean.
Yes.
Yeah.
So what is mean? Mean is just the arithmetic average, isn't it? So you just have to take the average of all these values. And how much is your average coming up? 92.42.
Okay.
Yes.
And what do we do actually for calculating the median? You arrange the data point into the ascending or in the descending order, isn't it?
Yes.
Yes.
Formula.
Yes.
But guys, in case you are working on an Excel file, you don't have to do so. That was more for clearing your your thoughts. If in case you are working on an Excel file, you can easily use the formula of median, and you will get your median as 89. What is mode? Highest repeating value.
Currently occurring
88.
88, right? Then what did we cover? Measure
Range,
of
measure of deviation.
measure of
Measure of
spread.
spread.
What did we cover is range. Now guys, there is no formula for range in Excel, but we have the formula for minimum and the maximum value. So you can calculate your maximum value using this Excel formulas. Then you can calculate your minimum value as well. Is 80, and your range is 110 minus 80. After that, what did we cover?
Standard deviation.
Standard deviation. What is standard deviation? That is the average distance of all the data points from your mean value. So what do? We calculate the average first. We subtract each and every data point from your mean value. Then we take a square of it. We divide that by n minus 1, and we finally take a under root of it. Isn't it? That's what we do.
Yes.
But guys, if in
Yes.
case you're working on an Excel, that's not even required. You can use the formula which is STDEV. Don't go for population. Now over here you will find three: STDEV.P, STDEV.S, STDEV. P stands for population, S stands for sample, but you don't have to get into that detail. Just look at the simplest one, which is STDEV over here, and you will calculate your standard deviation, which will come as approximately 8.99. So on an average, the data points are 8.98 units away from your mean value. After that, what did we cover? Quartile. What did we cover? Quartile 1, quartile 2, quartile 3. So guys, in case you wish, you can use this formula as well, which is there. Otherwise, you can use inbuilt formula which are there in the Excel file. You can go for quartile. Select this range. Which quartile we are trying to find? Which quartile we are trying to find?
First.
First one, right? Quartile 1,
Quartile 1.
isn't it?
Yeah.
Comma,
Quartile
comma
1.
1, comma 1. Comma 1 will give you your quartile 1. It comes as 86.5. What does this mean? It means 25% of the population is having a score which is less than 86.5.
86.5.
Quartile 2. Comma 2, since you are calculating your quartile 2. 89. Guys, one thing which you will notice, your quartile 2 and your median is same, and it will always be same because your median is also your, this is quartile 2 is also your median. Quartile 2 is also known as your median value. Okay. Then the last one is quartile 3. Comma 3. How much is it coming up? 100. What does this mean? What does this mean? It means that the 25% of the population is having a score above
90 to 100.
100. Above 100, right? Above 100. 25% of the population is having a score above 100, or you can say 75% of the score population is having a score less than 100 itself. Comfortable?
Yes.
Okay,
Yes.
very good. Now tell me one more thing. If in case Quartile divides the data point into how many equal parts?
Four.
If you want to
Four.
divide the data, if you want to divide the data point into 10 equal parts, then what would you use? Decile. Okay. If you want to divide the data points into 100 equal parts, then percentile. But most of the time you will be using quartile. It does not make sense to divide the data points into 100 equal parts using the percentile. Maybe sometime decile, but most of the time you will look at a quartile only. And so since box plot is also giving you the results from the quartile, that is something which I will teach you. Have you heard about box plot?
Yes.
Yeah.
So I will teach you box plot as well, and that is based on the quartile concept. Comfortable everyone? Yes, no, maybe?
Yes.
Yes.
Now guys, let's do one thing quickly. I hope everyone is using laptop or a desktop for attending this session.
Yes.
Yes.
Any one of you who is using mobile phone?
Hi.
Any one of you? Hemant is using. Hemant, if you can probably quickly get a laptop or a desktop if it is nearby you. Let's do one thing now. Whosoever is using laptop or a desktop, uh, open an Excel file quickly. Open an Excel file for me. Let message me in the chat window once you're done. Message on the chat once you have opened the Excel file.
Done. Opened.
Okay. Now guys, just do this. Okay. Just look at what I'm doing as of now. Okay. Just look at what I'm doing and then follow the path. So just look at this, what I'm doing. Go to data at the top. Do you see in my Excel over here, it says data analysis? Do you see data analysis in my Excel on the right hand side at the top?
We can see that. Yes.
Now check your Excel. Do you have the data analysis in your Excel in the data?
No, it's not visible.
No.
For some of you, it might be there. Whosoever have already activated, for some of you, it might not be there. I'm not talking about, guys, what if analysis. I'm talking about data analysis. Is it showing under your Excel file under the data?
No, it is not showing.
It is not showing. Okay. Now, guys, by default, it's not activated. You have to activate it. How many of you are attending this session using Mac? Any one of you?
Me.
Now, guys, I'm not sure about how you would be able to do that because I work upon Windows. I'm sure there is a way of activating that for in the Mac as well. So you have to try and Google that. Okay. I can only teach you using Windows. I'm not sure
Will
about
this
how to do
work?
that.
Sorry, will this work on Google Sheet too?
Sorry.
Google Sheet? Will this work on
No,
Google Sheet?
no, it will not work on Google Sheet. Google Sheet is a totally a different concept altogether. Okay. It will not
Okay.
work on the Google Sheet. Okay. Just try and search it using the Google, that where is the data analysis and how you would be able to activate it using the Mac. Guys, just follow the path. Okay, just follow the path what I'm showing you. Go to files, over here. Oops. Yeah, go to files. Do you see options over here at the bottom? Depending upon what version of Excel you are using, it might look and feel might change. So, but yes, you will have an option somewhere. So click on options. Do you see over here data add-ins? Click on data add-ins. Do you see over here it says Excel add-ins? There are many other, but you don't have to do that. Just click on the Excel add-ins and click go. By default, 4 or 6 different add-ins would be available to you, and I'm pretty sure everything would be unchecked for you. Everything would be unchecked. So guys, you don't have to check all the data points. You just have to click on the first one, which talks about analysis tool pack. You don't have to activate VBA. VBA is not required. That's Visual Basics, not required. You just have to activate the analysis tool pack and click OK. Now it should start reflecting under your data. Just check it out.
Yes. Yes, it is.
Everyone done?
We can see that. Yes.
Is it reflecting now?
Yes, sir.
Yes, Rohit.
Okay, like I said, I don't have any idea of how to do that in Mac. You have to try and Google. I'm sure there is a way of activating data analysis in the Mac as well. Comfortable? Okay, let's do this, guys. Now I will tell you a shortcut of how to do this every activity what we did right now. So guys, we'll go to data analysis. We'll go to data analysis. Do you see over here it says descriptive stats? Do you see
Yes.
descriptive stats? And guys,
Yes.
let me just tell you, if in case once you will become much more matured in the Six Sigma front, you might not be even Minitab might not be even required for you, because a lot of tests which you can perform in the Minitab, you can perform the test using the data analysis as well. I will try to teach you some of them, whatever it might be possible, but you will not be able to do it all of them. But yes, most of them can be done. Okay, using the data analysis, or if in case you don't have Minitab or it has expired, that should not be a constraint for you after some time. We'll click on data descriptive stats, I mean to say. Click OK. Oops. This kind of the box will populate up, guys. Over here, it will prompt you to enter the range.
Sorry, Rohit,
So
I think
enter.
the screen is stuck. I'm not sure if you're doing something.
No. Yes, I'm doing. Do you see over here? It's I have selected the range.
No, we see add-ins screen only.
I guess you have to
See,
refresh. We can see it.
Yeah, we
you can
can
see
able to see
only.
it.
Oh,
You're able
okay.
to see it, guys. Are you able to see? Please confirm.
Yes.
Yes, sir.
Okay. Guys,
Yes,
we'll go to
Rohit.
data analysis. Okay. We'll go to data analysis. We'll go to descriptive stats. Click OK. This box will populate up. Over here, it will prompt you to select the input range. Select this input range which we have of this data, entire data. Click OK. It will prompt you over here whether the data points which you have, does the first row contains the labels for you? Yes, so first row contains the label for me since it talks about data, right? And click over here on the summary stats. Click on the summary part and click OK. And here you go. Everything is ready for you on a click of a button. Everything has been done by Excel itself. So you have your mean value, you have your median value, you have your mode, you have the standard deviation, you have the range, you have the minimum value, you have the maximum value, you have sum, and you have count. The only thing which you don't have is your quartile. Comfortable?
Yes.
Maybe
Yes.
let me just increase the number of the data points for you. I will just increase some data points. Okay, guys, I'm just copying and pasting the data points. Just copying and pasting and increasing the sample size. Okay. Okay, let's try to do this. How many data points, if I have to perform the analysis on how many data points are there, 142 data points, I can go to data, data analysis, descriptive stats, click OK. I will select my input range, click on labels, click on summary, and click OK. And here you go. Everything is ready for you on a click of a button. You will get your mean value, median, mode, standard deviation, range, minimum value, maximum value, sum, and the number of the observations are 142. Comfortable so far? Is it good?
Yes.
Yes.
I'm sure it would be a little helpful for you as well. Okay. Another question. Have you downloaded Minitab?
Yeah.
Yes.
You all have?
Yes, but it's expired.
Sorry?
It's got expired actually. I've done it
Got
long.
expired. So you have two options. Either you can uninstall that from the registry and reinstall it, or you can use the online version as well.
Okay.
Let me just show you guys. I have also Minitab with me. I have Minitab 17 which I'm using. So you might have downloaded Minitab 19, which is okay. Now guys, how this Minitab will work. You have worksheet over here. This looks quite similar to that of an Excel file. In Excel file, we have A, B, C, D at the top. Okay. Over here, we have C1, C2, C3, which means column 1, column 2, column 3, so and so forth. Over here we have rows 1 2 3 4 5 6 rows, so and so forth, where this is the place where the data needs to be entered. And do remember that when entering the data, the header, hear me once again, the header should be pasted from here itself. Okay, the header should be pasted from here. This is the place where, guys, the you will get the information or the results would be displayed. Okay, this is the place where the results would be displayed. And look at the top, you have different options at the top. You have file, where you can open and save the existing file, worksheet, or the session window. Then you have edit option. In the edit option, you have clear, delete, copy, and paste. In the data, you can split the worksheet, you can stack and you can unstack the data, you can transpose the data, you can sort the data, you can rank the data, you can delete the data, you can erase the variable as well. In the calculator, you have calculator as well, and you can create some random data as well. Probability distribution is also over there. Lot and lot of distributions are there. Then you have metric as well. But guys, the major benefit of the mini tab will come to you when you will start using this stats and the graph tab over there, which is there at the top. Now mini tab is used not only by the Six Sigma professionals, but it is used by the various mathematicians and by the various statisticians as well. So you can, they are also the one which who are using it. So we'll learn what is important for us, and there could be a number of things which the mini tab will give us, so which might not be, everything might not be important for us. So we'll focus upon only those things which are important for us only. So at the graphs, you have different type of the graphs. You have your scatter plot, matrix plot, bubble plot, histogram, dot plot, box plot, bar chart, pie chart, time series plot, forecasting model is also there. Then in the stats tab is all the analysis which you will perform, and this is the area, guys, which we will focus upon in the black belt, right? Since you have to perform a lot of tests during your analysis phase, this is the piece where the most of the things will go into come into the play. Okay, then we have design of experiment as well, which we will learn in the analyze into the improve phase. Then process capability calculation and measurement system analysis will also be learned using Minitab itself. Okay. Guys, let's do one thing. Let's try to study this data. Let's say I have this entire set of data which I have. I will just copy and paste this data. Okay, I will just copy and paste this data into the Minitab. Look at this. I am pasting that from the header. Okay, I'm pasting that from the header. Once I paste it, I can go to stats, guys. I can go to stats, go to basic stats, which is there at the top. Over here, we have three different options, which is there at the top. I will click on the very first one first, which talks about display descriptive stats. Okay, this is the same thing which Excel also showed us. This kind of data, this kind of box will populate up, guys. Over here, what you have to do, you have to input variable, you have to input the data into the variable part. So just double click on the data and it should start reflecting under your variable tab. Okay. Now click on the stats, whatever information you want. Maybe you want mean, you want standard deviation, variance, quartile 1, quartile median, quartile 3, interquartile range, mode. And then you want some minimum value, maximum value, sum of squares you want, maybe whatever you want, and just click OK and click OK. And here you go, everything is ready for you on a click of a button. You will get everything into the mini tab itself. You will get your mean, standard deviation, variance, minimum value, quartile 1, median value, quartile 2, I mean to say quartile 2 and quartile 3, maximum value, range, interquartile range, mode, so and so forth. Comfortable with me?
Yeah.
Because you can easily copy and you can paste it anywhere where you want. Okay, you can even copy and paste it, and you can paste it over here itself like this. Maybe you can paste it anywhere wherever you want. You just take this example, you can copy and you can paste it in your Excel file, in your presentation. Then you can start writing the inferences from here itself. Yeah, so this is the mini tab data which you can easily copy and paste. Now guys, if in case you wish to see how the data is distributed. If you want to look at the graphical representation of a data, what you can do, you can go to stats, again basic stats. Do you see graphical summary? So click on the graphical summary over here. Yeah. So again, input the data and click OK. Now it will show you the distribution of your data, how the data is usually distributed for you. It is a normal curve, guys. It is a normal curve which I will teach you in the later in the session in the next week. It talks about the normality test. We have Anderson Darling test. This is just leave this as of now. I will teach you once we get onto this detail. Over here, you have your mean value, you have your standard deviation, you have your variance, you have your number of observations, you have your minimum value, quartile 1, median, quartile 3, and maximum value. Again, you want to make changes to the graph, you can easily do it. You can make changes. You don't want the background as grayed, you can change it. You want to make changes onto the graph, you feel that yes, you want to make some color coding as well, as per your own requirement. You can make the changes into the color as well, and you can copy the entire graph, control C copy, and you can paste it in your presentation. Then you can start writing the inferences from here. With me?
Yeah.
Yes, sir.
Yes.
Very
Hi.
good.
Hello.
Yeah, Divanjali.
Yeah. I just want to ask one thing. Will we also learn regression?
Yes,
Okay.
regression will come in your analyze phase. But how do you, what made you think about regression?
Actually, some point of time, I was doing a course in data analysis, a little bit online course, and from there I had a little bit knowledge about regression, but it's really difficult. So I just wanted to ask.
So it's definitely, Divanjali, you are right in saying that it's a complex topic. Okay, it's a complex topic, and it is a part of your data science, not even the data analysis. It goes to the level of the data science as well. It's a
Yeah,
forecasting
exactly.
model. Okay, it's a forecasting model. So in the Six Sigma, I will only teach you the basics of regression. I will not get into the too much of the regression analysis. But yes, I will teach you how to build a regression model. That is something which
Okay.
I will teach you.
Okay. I mean, that is only required in the black belt program.
Yeah, only in the black
Okay.
belt. If
Okay.
you want to pursue for data science as well, in that scenario, I would have taught you about higher studies into the regression as well. But not as of now, it's
Okay.
not even required. Let's cover the black belt first. Maybe we'll look at
Yeah.
more complex topics. Comfortable, everyone? So I have taught you this, what do you call it? Central tendency and the measure of spread using the different mechanisms. I have taught you using your uh, theory part, using the formulas part, using the Excel based formula. Then I have taught you using the data analysis in the Excel. Now I have also taught you using the Minitab as well. Comfortable?
Yes.
Yeah.
Yes.
I'm sure you will never not find any reasons not to do it, because you have all the options now to do your work.
Rahul, one thing, do you have
Rohit.
a help doc for using Minitab?
Yeah, so there is no help report. See, Minitab is self-explanatory. Look at this. If in case you feel that you need some information, okay, you're not sure about it, okay, you have your help and the assistant at the top. You can click on the help, click over here. This box will populate up, and over here you can mention, you can write anything, and it will give you the results. Let's say if I want to check about the median, okay, if I want to check about the median, I will just type median. I will click OK, and here you go. Everything is ready for you. It will give you the results from the median, and what is median is all about, how this needs to be calculated as well. So everything is there in the mini tab. You don't have to rely on anyone. Let's say if you want to calculate your range, okay, click range, and you will get your range over here. Over here it talks about how this range needs to be calculated. Everything is there within the mini tab. It will even give you the path to do it. Comfortable?
Thanks, Rahul. Yeah, thanks, Rahul.
Maybe you want to Rohit, not Rahul. Okay, now guys, let's do one thing before we proceed further to the next topic of the discussion. It's 1 hour and 40 minutes we are studying together. Let's again take a 9-minute breather at the same time like we did yesterday. Come back, then study. Okay.
Okay. Yeah.
Well, please be
Yeah.
back
Perfect.
by 4:50,
Okay.
4:51 on a higher side.
Perfect.
So I am also putting myself on the mute, guys, so you will not be able to hear me out. All right, everyone, I'm back. Please confirm your availability as well.
Yes.
I'm available.
Yes, Rohit.
Great. Others?
Yeah, join back. We're back.
All right. All right. So guys, I think let's start the session now. Let's start with the session. This is something which we have already covered. Yeah. Now guys, let's start with the 5-step methodology, which is define, measure, analyze, improve, and control. Because there are various. Do you remember the medical analogy which I gave you yesterday? Do you remember the medical analogy?
Yes.
Yes.
Okay, great. Okay, there are various activities which are performed within the define, measure, analyze, improve, and control. Let's look at the high level overview of the activities which needs to be performed. Guys, what do you think are the things which needs to be done in the define phase? What do you think would be done?
Define the problem.
Let's say define a problem. Okay, what else?
The scope of the project.
Very good. Okay, what else?
Problem caution.
Problem what?
Problem. What we face in the process.
Okay. So guys, think from this angle. Let's say let's say there's a problem. Okay, let's say there's a problem which you are facing in your area, whatever problem which you might be facing. You want to remove that, right? You want to reduce it, isn't it? That's the reason you want to do an improvement project.
Yes.
What's your thought, guys? Let's say, do you think, guys, you will think about doing a project and you will start doing it from tomorrow onwards? Can that be done? Would you be able to do so?
No.
Or do you think you would be requiring some kind of approval first before initiating an improvement project? Do we need sponsors and do we need stakeholders?
Yeah, certain projects should get
Isn't it? We need the sponsors, we need the stakeholders as well. I guess, can this happen? Let's say during the course of your project, you might need some amount of money as well. You might need some amount of budget as well for implementing the solutions, which you might identify in the near future. Would you be spending the money out of your pocket?
No.
No. Who's getting the benefit out of doing the project?
The organization.
So if the organization is getting the benefit, so it should be the organization only, isn't it? Who should be spending the money as well on solutioning deployment as well? With me?
Yes.
How about this? Let's say you have thought of a solution which will cost you, let's say, $1 million, hypothetically. Do you think you will ask for 1 million and the organization will give you? No, right?
No.
They will not.
No.
So what you need someone who is a sponsor as well, isn't it? Who will be sponsoring your project within the organization. Might be sitting at a leadership level and who are the approving authorities, correct? Let's say, guys, you have identified a stakeholder. You have identified a stakeholder and you went up to them. Do you feel that they would be asking you a number of questions since how long the problem is existing, where the problem is existing, why the problem is existing, what are the root causes, what are the solutions, how much benefit the organization will be getting? Are these kind of the questions which are obvious, which the stakeholder might ask? And if you don't have the answers for them, what will happen?
You wouldn't be able to
the project will not
justify.
get approved.
Sorry?
You would
The
not be in a
project will not
position
get
to
approved.
justify the reason and the impact of the.
Absolutely. If you don't provide them the answers or the question which they have put up, your project will not be approved. They will not approve the project, isn't it? Because hence what we say that uh, defined phase is more like a sales pitch. So it's not picture, it's sales pitch. It's a type of mistake. It's more like a sales pitch because where we try to anticipate the questions from the stakeholder and we try and answer them. Okay, we try to anticipate what are the questions which the stakeholder might ask us. We will try to prepare beforehand with the data so that we are ready with the answers, because getting the time of the stakeholder itself is a very challenging task itself. There's a couple of the things which are done in the define phases. You would be defining the problem. Excuse me. You would be defining the problem. You would be defining the goal statements as well. You would be defining the milestones as well. Couple of activities, guys. Couple of things which are not done. Okay, hear me. Couple of things which are not done within the define phase. Okay, couple of things which are not done in the define phases. You do not tell root cause or solutions. Why? Why don't we don't tell solutions or give root causes?
If we already know the root cause and
That
solutions,
will be outcome of the project. So
Yeah, absolutely. Someone was just mentioning that correctly, guys. If you are already aware of the root cause or the solution, then it is not a Six Sigma project. Okay. Six Sigma projects are done only in those scenarios, guys, where the root cause and the solutions are unknown to us. If the solutions are known, why do you want to do a Six Sigma improvement project? Just go ahead and deploy the solutions. There is no need of doing the improvement project. With me?
Yes.
yes.
Yeah. So Six
Yes.
Sigma projects are done only in those scenarios, guys, where the root cause of the problem is unknown. And if in case it is known, you will not be able to, you should not actually do a improvement project. Okay. And guys, what do we do? What do we do actually in the analyze phase? What do we do actually in the analyze phase?
Find the root cause.
By studying the data, right? By studying the data, you will try to identify the root cause, isn't it? Do you feel, yes, do you feel that a situation can occur where the data on which you are working is not correct? Can that occur? Can the data be incorrect as well?
Yeah, possible.
Yes,
Now,
possible.
if the data on which you are working is incorrect, would you be able to identify the right set of solution? I mean to say, would you be able to identify the right root cause?
No.
No, right? Since your data is incorrect, you will not be able to identify the right root cause of the problem. Hence, guys, what is important is you should first try and identify whether the data on which you are working is correct or not. You will first try to identify whether the data on which you are working is correct or not. If in case the data is not correct, you should be first correcting the data, then go ahead and analyze the data without validating whether the data source is right or wrong. You should not analyze the data. Okay? This is something what we would be doing in the measure phase. We would be validating the data whether the source of the data from which we are getting it is correct or not, whether the um, data which we have extracted is right or wrong. If it is not good, you have to first correct it before analyzing the data. Comfortable with me?
Yes.
Guys, in the
Yes.
analyze phase starts with the identification. Hear me, this is important. Okay, identification. Analyze phase starts with the identification of the potential. Okay, important word over here is the potential reasons which might be causing the issue. There can be 15 or 20 reasons which you might have identified, but all of them might not be impacting the problem, right? Isn't it? All of them might not be the reason of the impact. Now, in order to identify, guys, in order to make sure, or in order to identify out of these 15 or 20 factors which you have been able to identify, which factor is actually an impacting factor because of which the problem is existing, we would be doing the hypothesis testing. By doing the hypothesis testing, you would be able to identify the actual root cause of the problem, maybe from 15 or 20 potential reasons. Yeah, clear? Now guys, once you have been able to identify the root cause of the problem, we would be moving to the improve phase. Improve phase is all in all about identifying the right set of solutions first, then deployment of those solutions. Once you deploy those solutions, guys, the processes should start improving, and we would be moving to the last phase of the DMAIC, which is the control phase. And control phase is all in all about sustaining the improvement which you have been able to make. With me?
Yes.
Yeah.
Rohit, one
Yes.
question. We were trying to tell that we should validate the data or validate the data in the measure. Suppose in the system, like whatever the data has been inputted, if you input a crap data into your system, obviously the output also will be crap, no doubt in that. But is there any other way to ensure that the data is 100% authentic?
Okay. Srinath, you are actually just trying to jump the guns. If you just look, I am just trying to give you the overview of the different activities, right? Isn't it? This is just the overview,
Yeah.
what's coming your way. Let's get into the measure phase. Let the measure phase start after 2 weeks. Then we'll discuss this question which you have.
Okay,
Let's
okay,
get
okay, got
into
it.
the details, right? This is just an overview what I'm providing you. This is not the
Sure, sure.
entire end of the Six Sigma.
Got it.
Okay, these are some of the tools which are used. Okay, there are many other, there are some of more tools as well, but yes, these tools which you are just seeing on your screen, I would be able to teach you at least 90% of these tools. Okay, 90% of these tools would be taught. Maybe 10% of the tools which I might not be able to teach you, those are more complex and are used more in the master black belt courses, not in the black belt. But yes, at least 90% of these tools which you are just seeing would be covered. So I will be covering the project scope, project charter, business impact, VOC, Kano model, CTQ tree, process map, data collection, control charts, Pareto, prioritization, MSA, process capability, RTY, cause and fact, FME, hypothesis testing, ANOVA, scatter plot, design of experiment to a certain extent, if not in detail, brainstorming, full factorial, yes, fractional factorial, yes, I will teach you. Implementation plan, yes, we'll cover the SPC or standard operating procedure, SOP, data collection plan, control plans, MSA recheck, and the project summary and the lesson learned. So we are covering at least 90 to 95% of the activities within this. Yeah. Fair call. Shall we start? Shall we move ahead?
Yes, Rohit.
Yes.
Sure.
Guys, let's look at this. Let's say this is me. Okay, this is me who has a very bad habit of reaching to office quite early in the morning. Okay, I try to reach office at 6:55 in the morning. Sometime I reach office at 6:30, sorry, 6:50, and sometime I'll be able to reach to office at 7 o'clock as well. What do you think, guys? Is this acceptable? Is this acceptable? Do you think I would be able to reach exactly at 6:55 every day?
No.
No, I guess this is fine.
Is this
Quite
fine with you?
acceptable.
Yeah.
Yeah. Guys, what do you think could be the reasons? Talk about this. What could be the reasons because of which I was not able to reach exactly at 6:55?
Maybe a traffic.
Maybe no.
Yeah,
Traffic
start
will not
time.
impact me. Traffic will not impact me by 5 minutes.
Okay, you woke up late.
Again, might not impact.
You probably met a colleague outside.
Maybe I might was maybe my friend was smoking and he just asked me to give a company. Though I don't smoke, still I was a passive smoker in that scenario. Could be, isn't it?
Yeah.
Or could be maybe your office is on 10th floor. You are waiting for the
Lift.
elevator. You are waiting for the lift. Once the lift comes in and you notice that the lift is completely full, it's completely filled, there's no space in it, then what you have to do, you have to wait for another 5 minutes or so before you would be able to reach, isn't it? How about this? Let's say how do you mark your attendance? Biometric or swipe card?
Swipe card.
Right.
Swipe card.
Swipe card, right? Now, once it can again happen that once you reached at that location, maybe there were other folks as well. There were other individuals as well who were standing in queue, and they were standing prior to you, right? They were in front of you, and that will impact you by 5 minutes, isn't it?
Possible.
Or how about this? How about this? These days, coronavirus is going on. Once you reach office, do you feel your admin department would be checking your temperature as well? Or they might be doing the few, they might be giving you certain sanitizer as well, and that might impact you by 4 or 5 minutes again, isn't it?
Possible.
Yes.
Think from this angle now. Let's say the team, you ask your team to deliver a productivity of 100%. Do you expect them to deliver 100% on each day?
No.
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 If they deliver it 95% on some day and they deliver 100% on 105% on some day, is it acceptable to you?
Yes.
I'm sure it is. Is it? It is, right? Isn't it? You cannot expect them to deliver 100% on each day. Some day they will be able to deliver more, and some day they will be able to deliver less as well. With me? Yeah. Now, guys, what are these? These are known as your common cause variation. Okay. These are known as your common cause variation, which will always and always exist in the business. You will not be able to take it out, and these are known as the inherent variability in the process by design itself. There could be thousands of the reasons, and you will not be able to even identify why this could have occurred, and you will not be even able to take them out. Comfortable? How about this? Let's say today I reached office at 6:30 in the morning. What do you think could be the reasons? What could be the reasons why
Got
I
up
was able to
early.
reach office at, sorry? Yeah, maybe I might have got up early.
No traffic.
No traffic, maybe. Why got? Okay. What else?
You are the
Some
first
pending
one
work,
to reach.
Sorry?
some pending work or urgent work.
Yeah. Yeah, maybe some pending work or some important work which was supposed to be finished early, isn't it?
Yep.
Maybe just look at this. Since these days Corona is going on, I am sure each one of you or some of you might be working from home, isn't it? So the traffic on the road is very less. Do you think this situation will continue or this situation will change? And one day you will again be stuck in the traffic jam?
Will change.
This will change and once again you will be stuck in the traffic jam, isn't it? With me? Look at this. Maybe the watch was running little fast, or maybe I come down walking to my office. Today I got a ride, or maybe the bus driver took some shortcut, or maybe I might have stayed at a friend's place which was nearby, hence I was able to reach office at early in the morning. Now guys, these are known as special cause variation. Okay, these are known as the special cause variation, or we call it as assignable cause variation as well. Why do we call it as assignable cause? Because there is a reason why it is actually occurring, and you would be able to assign a reason to it. Okay, that's the reason we call it as assignable cause variation. And guys, once this occur, it would be easy for you to identify and eliminate as well. Today I reached office at 7:20. What could be the reason?
Traffic.
Okay,
What?
okay, I agree.
Bus will be late.
Sorry?
Vehicle problem.
Agree.
Yes. Your watch stopped
Maybe,
working.
yeah, or maybe my vehicle broke down, isn't it? or maybe there was some VIP movement which was happening, because of which there was some traffic jam as well, because of which I was not able to reach on time. I reset 7:20. Do you think, guys, this situation will occur on daily basis?
No.
No.
Do you think this will occur on ad hoc basis? It will occur on ad hoc basis, right? Not on the daily basis, isn't it? Again, these are known as your special cause variation. Now, guys, the common cause variation is one which will always and always present in the business. There are a lot of reasons, and you will not be able to take them out of the business. Special cause is one which is not always present, and you can easily identify the reason and eliminate them as well. Because why is it important to know the variation? Because it tells us whether the process is stable or unstable. A process under the influence of a special cause is said to be unstable. A process under the influence of a common cause variation is said to be stable. An unstable process may lead to customer dissatisfaction. Look at this. Let's say day. Monday to Friday, we have 5 days. Okay, just take this example. Let's say this is the sales which you are doing on daily basis. Target which is being given to you is 100 sales per day. Okay, let's say on Monday you did 95, then 105, then 98, then 102 maybe. Do you think this is acceptable or it is not acceptable? Is it acceptable? Can you tell me the reason why I was able to do 95 or 105?
That's a common cause variation, actually.
You will not be able to tell me the reasons, right? Isn't it? Because there are thousands and the thousands of reasons because of which this could have occurred. And these are known as your common cause variation. Let's say on Friday I did 30. Is it good or is it bad for the business?
Bad for the business.
Bad.
Do you want to replicate this situation or do you want to refrain from this situation?
Refrain.
Reframe.
Yeah. And this is known as your
Special cause.
Special cause
special
variation.
Cause variation.
And why could this have, why this situation could have occurred? What could have triggered from this situation from happening? Tell me.
Absenteeism.
Okay, I agree. Lot of
Strike,
absenteeism is, sorry,
Public holiday.
public holiday. Okay.
strike, or
Yes, strike or okay. Or maybe it could be the reason. Maybe you do not have the proper stock in hand, isn't it? You did not do the proper stocking. You do not have the proper stock to sell. This can happen as well, isn't it?
Yes.
Yep.
How about this? On Friday you sell 140. Is it good or is it bad?
It is good.
It's good.
Would you like to replicate this situation?
Yes.
Can you tell me the reason why this could have occurred?
A promotion or something?
Yesterday night itself, there was a, in Amazon, there was a discount offer which
Discount.
actually got expired, isn't it? What do you call it? I even can't remember. It is called as Big Billion Days or what?
Offers.
Something like that, right?
Freedom
Like
sale.
that. Yeah, so those are the things which might have triggered for the sales to be high, right? This is known as your special cause variation. Now, guys, having a special cause variation in the business does not mean it is an error. Okay? That does not mean it's an error. You have to check, you have to go and you have to see whether it is good or is it bad for the business. If it is bad for the business, you should try to identify the reasons and eliminate those reasons. And if it is good for the reasons, I mean to say, if it is good for the business, again, try to identify those reasons and redo it. Comfortable?
Yes.
And guys, trust me, all these things which I'm teaching you, I will just sometime I will link all these together. Okay, these are just the dots which I am making as of now, and one time in a day or so I will link all these dots. So do remember all these things. There is a linkage behind it. Okay, let's talk about this,
Rohit,
guys.
this slides will be shared with us, right?
So this slide is already with your training coordinator. I'm sure they might have already shared with you. Not reach out
Okay,
to them,
fine.
ask them to share the slides with you.
Sure.
They
Okay,
have
fine.
the
Thank you.
entire slides.
If any of you guys have, can you guys forward to us?
Who, me?
No, probably you or anyone.
I think nobody has received it yet. If in case they have received it, they might be able to share it.
No, I haven't.
Reach out to your training coordinator, they have it. Just call them up.
Rohit, did we get the working Excel also from
So they have
the?
this file, this Excel file. They also have their Excel also.
Okay.
They also have an Excel in which the data is there. And guys, trust me, next week onwards, let's do one thing. First, let's complete this topic. Then I will take another 5 minutes or so. Okay, I will require 5 minutes more today. Then we'll discuss few things. Okay. VOC. Now, guys, these are some of the themes or some of the reasons because of which it might be important for you to initiate or do a improvement project. One of the reasons is VOC. VOC stands for voice of the customer. Guys, let's say there are a lot of complaints and a lot of escalations which are coming from the customer or from the client. Do you think it would be important for us to initiate or do a improvement project in that scenario? Will it become important for us?
Definitely.
Isn't it? If customer is saying that they are feeling the pain, it will be important for you to do the improvement project. Yeah. How about this? VOB stands for voice of the business. Let's say there is a lot of attrition, absenteeism is happening, and the organization is saying reduce the cycle time or reduce the repeated errors. Do you think it would be important for us to do the project?
Yes.
Yeah. Think from this angle, guys. Let's say you have ordered something from any online platform, let's say from Amazon or Alibaba or Flipkart or Walmart or any other platform. Let's say you ordered something and you came to know that there is a 50% attrition which is happening within Amazon as of now. The riders are not turning on time. Would you be concerned about the attrition which is going in the Amazon, or you as a customer would be only concerned about your product and your services?
Customer cares for what he wants.
No, you tell me. Would you be concerned about the accuracy? I mean to say the attrition of Amazon, or just the product? I think just the product, right? That's what you also said,
Yes.
Srinath, isn't it?
Yeah.
So as a customer, I hardly care. I hardly bother whether it's a 50% attrition or it's a 100% attrition within the Amazon. I care about my product. But do you think from the business perspective, from Amazon perspective, they must be worried about the attrition management?
Certainly, yes.
Isn't it? So something which might not be important from the customer perspective, but might be important from the business perspective. Your leadership team might be saying to you that they are feeling pain, do something around it. In that scenario, you might have to even initiate an improvement project. So it's a need of a business, not the customer, but the business. Comfortable?
Yes.
Okay. And finally, we have one more thing. It stands for RTY. What does RTY stands for? Rolled throughput yield. Do you all understand what is RTY?
No, no.
No, guys, RTY stands for rolled throughput yield,
Yes.
which means output of one department act as an input for another department. Okay. Output of one department act as an input for another department. Take this example. Let's say there are three different departments, guys. Department A, B, and C. Okay. There are three different departments, and each department is operating at a accuracy percentage of, let's say, 90%. Okay. 90% is the accuracy percentage of each and every department. And over here we get the inputs. Input goes in, and then we get the output, isn't it? Input goes in and output comes out. Let's say, guys, the input goes in, input is 100% correct. How much would be the output of A? How much accurate would be the output of A?
90%.
90.
90.
Yeah.
Now B does not know that the input which is or they are getting from A is only 90% correct. B will think that they are getting the input which is 100% correct, but the B is also operating at 90% accuracy. So how much would be the output of B?
81%.
90% or 90%, right? 81. Now C does not know that it is they are getting the input which is 81% correct. They will also operate at 90% accuracy. How much is the accuracy of C now?
72%. Around 72 to 73.
73 approximately.
Output will
Isn't
be
it?
72%.
Now think from this angle. Let's say, what does this mean? It means production was done of 100 items. Defective items were 27. Don't you feel that
27.
it's a too large number?
Yeah.
Yes.
As an organization, you might be concerned about it, right? So let's say maybe once you did the analysis, you find out that the out of 100 product, 27 products are defective. Once you start mapping this entire activity, you realize that in order to make a product, there are 3 different departments which are getting involved, A, B, and C. And you also notice that each and every department is operating at a hypothetically operating at a 90% accuracy. Now if the target for you is to take this to to a target of 86% or 85%, in fact, what should be done? What can be done?
Improve efficiency of A and B.
A. Should I improve the accuracy of A? How much? 95. How much should we make? 95. Okay.
97.
Still. Okay. 97. Okay. Still we are sitting at 79% only then.
No, second B also we need to.
A and B.
Okay. How much? 97.
97 and 95.
Okay. Then still we are at 83 then.
100.
So in this scenario, what is coming to the picture is, guys, that if you have to improve the overall efficiency, responsibility cannot be given to one of the departments for improving the overall system, isn't it? The responsibility needs to be owned by each and every department. If each and every department can improve their accuracy level, then you would be able to meet the numbers, isn't it?
Yeah.
With me, yes, no, maybe, comfortable, everyone?
Yes. Yes.
Yes.
Yes.
Yes.
Yes, sir.
Very good. Now, guys, I'm not moving any forward. This is a new topic which we are starting. Now we still have another 4 minutes left. A quick thought. How about this? Once we start the project, now guys, you tell me, do you want to learn only theory part or do you want to do the practical as well? You decide.
Yeah, practical.
Practical as well.
Practical as well.
But for practical, we will not have that amount of time. Okay, we will not have that amount of time where I would be completing the practical as well for you, and
We're okay
I
to
will be
search for a
taking.
while.
Sorry,
We're okay to search for a while. You can take some additional time.
but I'm not ready to sit now. But you are ready to spend for more time, because the time which has been dedicated to me, I will be spending that amount of time only.
Or you can
See,
give us
hear
some
me out.
assignments so we can work out.
No, hear me out. What I'm saying. See, I have to complete the entire course as well within the stipulated amount of time which is being given to me by your training coordinator as well. Now, guys, we'll do one thing. Okay, if you want to really learn Six Sigma practically as well, so I will be from the next week onwards, I will give you some assignments as well. Okay, I want you to do a dummy project. Okay, hear me, I want you to do a dummy project. I will tell you how that needs to be done every day once we meet it, and next time once you come back, show it to me. That That's how
Okay.
you would be able to learn. Okay. Otherwise,
Yep.
trust me, it would be a challenge for you. Now, for that, what does this mean? It means more commitment from your side. After the entire session is done, you have to work upon the data, guys. You have to work with me.
Okay. Yes.
Only
Yes,
then you would
Rohit.
be able to learn, guys. Otherwise, I will just complete the course and it will be difficult for you to do it later on, which I don't want. Okay, I want you to learn along with the training part. With me? Comfortable?
Yes.
I will
Yes.
share the data.
Yeah.
I will tell you how what needs to be done, and everyone have to make sure whosoever is ready to invest and ready to learn, they have to do it. Okay, and then and if you face any challenge, come back next day and share the challenges with me, and I will solve that problem for you. With me? Okay.
Yeah, that will work.
Sure, sure.
Okay.